it's my great pleasure to everyone, welcome to everyone in the room and on Zoom, and my great pleasure to introduce our visitor today and speaker, Liam Tate, who is the founder and CEO of Kaitera. Hope I pronounce it correctly because I had some problems.
Everything's correct so far.
So, global leader in air quality monitoring, management, and analytics. Now, I can say this absolutely without any hesitations that you would find few people who have this expertise in monitoring and understanding the sort of holistic building issues as Liam has. Liam oversees the technology of Kaitera, and he serves at the International Well Building Institute technical board, and he serves also in many other organizations. Laptop, Rafat. Okay. Including the American Industrial Hygiene Association, Indoor Air Quality Task Force, and several other organizations. Liam speaks at many different conferences. What I didn't know, and I only learned from the brief CV, that you were a great storyteller. So that's another.
We'll see.
Liam and I first met in March this year at the forum in San Francisco, the Stanford Forum on Air Quality. So that forum for 2.5 days, discussed issues related to sort of global approach and challenges to indoor air quality. We formed 3 task groups from that work, and we are working on several different documents, which hopefully will be next steps in guiding the world in the quest for clean indoor air. Now, today Liam will be talking about air quality monitoring, and during the course of the day, we are looking forward to hear more about sensors and how we can work together. And we are very pleased that you, not only that you came here, but you accepted to work with us. So, Liam, the floor is yours.
Great. Well, thank you so much. It is definitely an honor to be here, and I always really like sessions like these. It's my day-to-day is spent very much talking to people that are trying to improve air quality, but these are often large government bodies. They are Fortune 500s, huge school districts, et cetera, and so. But personally, I'm very much a nerd. I like to geek out and go deep into all of the research side of things, very technical questions, and so yeah, it's always enjoyable to come to somewhere like this and kind of get into the weeds. So this is kind of the presentation, but I think feel free to stop me at any point in time and be like, what does that mean? Or I disagree. Why do you think that? And have a healthy debate, etc. So with that, maybe just a little bit of background about myself. I grew up in Switzerland. I went to university in Canada, and I've spent a significant portion of my life in some of the world's most polluted cities, from Beijing to New Delhi to all other places that have issues with air quality, which is kind of what got me started in this industry. Prior to this, I was essentially a full-time professional adventurer. So I traveled the world making documentaries and television shows about living in the jungle, surviving in the ocean, being dropped off on deserted desert islands. So that's a large career shift, to say the least. With that, let's see if we can get the technology working. Next slide. Oh, okay. Do I have to? Oh, that's a bit tricky. I have to use the scroll. All right, so what we're going over today, and like I said, feel free to just jump in at any time. I will keep an eye on the screen here, the Zoom, so if someone wants to, say something, feel free to use the hand up emoji thing. I thought would give a little bit of an introduction into Kytera and what we do, just so that there's some context and background. Talk about what I see as kind of the state of indoor air quality monitoring technology globally, where we are today, and then kind of the meat of this is all the key learnings that we've had as an organization about what works and what doesn't, and what are probably some of the pitfalls that people do not expect but end up running into. So with that, just some background. Kytera is a global company. We were founded about 11 years ago, and we create sensors, so physical air quality monitors. We work deeply on the actual raw sensor technology that gets embedded in those monitors. We also create software to gather all of that data and bring it together and try to turn it into something useful, because just having data is not useful. You need to do something helpful with it. And yeah, our solutions are used on the corporate side by Fortune 500s all around the world. On the education and school side, we've got deployments across sort of statewide across a lot of US states with thousands and thousands of monitors. One of our biggest corporate clients, Amazon, they have over 25,000 air quality monitors installed. And some of the most iconic buildings in the world, so things like the Burj Khalifa, the Empire State Building, they're all using our solutions. So, quick history of Kytera. And in case anyone's curious, this is just an example of an air quality monitor that we make that is busy telling us that right now the CO2 levels in here are 690 and there is no PM 2.5, among many, many other things. So quick history. This is sort of where we got started. This is Beijing in 2013. I was in Beijing at the time during what was pretty much the world's worst air quality. There was several weeks where PM 2.5 levels were close to 1,000 micrograms per cubic meter. If you were on the 14th floor of a building, you could not see the ground underneath you, just complete insanity. And a lot of people woke up to this, I'd say the broader public globally started to wake up to the fact that air quality was an issue. At the time, my wife was coming over to visit, then girlfriend, and as a child, she had asthma. She had, like many children, have grown out of it until she landed in Beijing, and then she just basically couldn't breathe, and she kept coughing. And we used to joke that you could tell the AQI by counting how many coughs she had in a minute, like the coughs per minute. She was actually a very, very good human sensor of PM 2.5, unfortunately. And so that sparked, with that combined with actually the fact that I found myself living in an apartment, and for the first time, I went into an apartment and I developed a skin condition, like eczema on my arms, which I had never experienced. And I was certainly not able to tie together the fact that I was experiencing some strange skin condition to what was in the air in that apartment. It turns out it was poor building materials, basically high levels of VOCs. So all these things kind of coming together woke us up and said, why is it that we have no idea what is in the air that we breathe, and why is it that it is so hard to find out? At that time, there were, if you weren't working in a university with access to lab equipment, there was really no way to answer that question. And so what was a weekend passion project got out of control, and many years later, here we are. This was our first project. It was essentially the world's first, I want to say, affordable air quality monitor. It was called Laser Egg. We released this in 2014. So really, I know Lydia mentioned several times the plant tower sensor. We were heavily involved with the development of that sensor, writing the firmware on that, and we were the first ever monitor to use these low-cost sensors. It was hugely successful. These devices, our company actually had a different name at the time, Origins Technology. These devices were used by the BBC, CNN, to go and report on the actual levels of PM 2.5 in all of these cities around the world that weren't typically sort of reporting publicly on this. They were so popular that they ended up in the homes of many, many people. One day we got a phone call from Apple, said, we love your product and we want to sell it in the Apple stores across Asia, which as a 6-person startup at the time, you don't expect to get a phone call from Apple. And so yeah, these products were in the Apple stores in China, in India, in South Korea, and many other places. And that's kind of how we got started. It's shifted a lot since then, and really we have ended up focusing entirely on real estate rather than sort of solving solving consumer individual problems. There are many options that have come out that are really great for understanding air quality, like that one right there, AirNet. There's many sensors that have been created that do a great job of solving the problem for an individual who wants to know, what am I breathing? Even IKEA has like a low-cost sensor. Won't comment on the quality necessarily, but there are many options at very affordable prices. What we found was really the gap is buildings like this one. The technology that you use as an individual and the technology that you need to use in a building to actually create a healthy building are incredibly different. On the surface, they sound similar. They're both measuring air quality, but that is where the similarities end. And if you try to take a consumer monitor and you put it into a building like this or into schools, you run into all sorts of problems, which I'll spend most of this time talking about. And so really that's where my efforts have gone, is trying to understand, why is it so hard to get adoption, or why historically has it been so hard to get adoption of sensing technology in the places that actually matter, which are our schools, our public buildings, our offices, all of these places. And I don't need to tell anybody here, but the reason why a decade later still focused on air quality is because it is such a huge issue, right? I'm sure everyone on this call knows the stats. There's 7 million premature deaths, etc. I think what a lot of people don't realize is it's hard to quantify that number. The way that, so you've got the WHO, many other bodies that will provide an estimate of roughly 7 million premature deaths. The way that I always look at that is that's the same number of combatants that were killed during the Second World War each year. Just to kind of put some perspective on that, right? Like how much effort were we going through in the Second World War to stop it versus how much are people talking about fixing air quality? There's a significant gap there. And obviously it impacts literally every single person in the world. Right? I always have a screen like this up because I'll be presenting in the UK or something and people go, oh yeah, air pollution, that's a China problem. It's like, nope, 1 in 10 cases of lung cancer in the UK is from air pollution. And obviously, on kind of the business side, which is where a lot of the people that we work with, improving IAQ obviously has positive business impact. If you're an employer, increased air quality, better cognitive performance, lower sick leave, higher employee satisfaction, all those things that everybody here knows. I think one thing that is worth noting is that, and this is trying to bring in some of the key learnings, it's really important to tie these numbers to the things that the people care about. So for example, I see a lot of people going to landlords. So you might go to, in Australia, Lend-Lease or Dexus or Cbus or these large developers and owners and talking about things like employee productivity. As a Lend-Lease, I don't really care. They're not my employees, they're my tenants' employees. And so a huge thing in this is understanding what is the pain point of the person who has this problem that we're trying to solve, and having the right numbers for that. So as a Lend-Lease, as an example, that owns a large, a giant building, they're going to care about retaining their tenants. And so if they can communicate about the benefits that they're providing to their tenants to increase their rental yield, then that is something that they are going to care about. Conversely, if you're talking to a Deloitte, for example, who might be a tenant in that building, what they care about actually is employee productivity. Because how does Deloitte measure success? They measure it through billable hours, right? Consultants, billable hours, if you can make people not waste time because they're falling asleep, you get more billable hours. So, there's within like the world of academia, there's so many statistics that we have about why air quality is important. It is absolutely critical to take the ones that are going to resonate with people that you're talking to. So yeah, what going back to what we do, we've sort of created two, let's say, product lines. One is wired devices and one is wireless. So wired devices basically means that they're hardwired typically for power. Wireless means that they are battery powered. This is incredibly important because different projects have very different needs. I'll do a quick quiz in a moment on some of the, why this is important. Suffice to say, you can't have one solution that's going to fit everyone, and that's why kind of over the years we've ended up with devices that have screens, devices that don't have screens, devices for use outdoors, devices for use indoors, devices for uses in the actual ductwork to measure return and supply air. Because all of these things, there's sort of many different use cases, many different users. And one of the big historical challenges with air quality sensors is the fact that they can drift and the importance of calibration. And so this is an actual photograph of a sensor on the left, brand new, on the right, after significant use. And you will see why the sensor on the right probably is not going to provide you with a very accurate reading anymore. For the people in the room, I'll just move the Zoom crowd over there. So these things can get really nasty on the inside. I've seen spiders crawl inside and die. I've seen cobwebs. I've seen all sorts of things. And so while we have made huge increases and improvements in sensor technology, there are still some fundamental challenges. And so that's one of the reasons why I'm a really strong advocate for making sure that the sensors inside these devices can be removed and replaced. So, for those that are in the room, I'll show you. I have a device here. This is the actual sensor. It's kind of like a printer cartridge. I can just take it out and I can replace it with a new one. Electronics like this should be designed to last over a decade. Sensors do not last over a decade, despite what many spec sheets might try to convince you of. If you actually run the data on thousands of devices for many years, you'll see that 3 to 5 years in, depending on usage, there's suddenly going to be a huge divergence, and a lot of them will start to not perform. We're the first people to come up with anything like this about 2017. I think it's becoming very much industry standard at this point. And just to give kind of one example, this is, I mentioned there are wired solutions and there are also wireless solutions. Wireless solutions really are something that has only become possible, I'd say, in the last year or so to do well. So this is a device, it's completely wireless, it's battery powered, it runs for up to 8 years on battery. If you have experience with these sensors, you might be scratching your head wondering how it's possible. The answer is many years of engineering, hard work. It measures, just as an example, PM 2.5, PM 10, VOC, CO2, temperature, humidity, occupancy, atmospheric pressure, light levels, ozone, carbon monoxide, nitrogen dioxide. And power and connectivity are both completely wireless. We've also realized that it's important to have sensors that sort of measure a wide variety of different things. So again, this is sort of one model that can be configured in three different things. And the reason for this is this room, for example, I'm sure has a thermostat probably sitting right over there that's measuring temperature, humidity, possibly CO2.
Return.
Okay, the return. So most new buildings will have those, and it's pretty much every room needs to have these built in. And so by making these essentially in the same device, but by having these different modules, we're able to make it so that sensors get built into the base building, basically replacing the traditional thermostats. That's important because you then don't end up sort of duplicating, like you don't end up with a thermostat in the wall and then an air quality monitor next to it and then like an occupancy monitor next to that, because that will get shut down by engineering. The budget will come in 5 times higher than it should be because you have so many different sensors, and architects will like bite your head off. And unfortunately, in many projects, architects actually have a really strong say, and they hate seeing 5 sensors on the wall. I've seen incredible projects where they were so focused on creating healthy environments, blah, 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 and it would just get vetoed at the last minute by an architect that says, looks ugly. Which is a horrible reason for a project to die, but it is what happens in real life. Oh, well, I'm sorry. Normally this is a little video here, but this is a PDF, so it doesn't play anymore. So I'm going to talk a little bit about kind of the whole like wireless thing here and battery power, because I think it's actually really, really important, but it's useful to provide context on why it's important. So we'll do a quick quiz here. Let's say a monitor costs, just for argument's sake, $500. That's kind of a typical price range. What do you think it costs? So your typical kind of wired monitor where you need to power it through an actual cable. What do you think it costs to install that monitor on the wall? So if I'm like the university, for example, monitor costs $500. What does it cost to actually install that? Anyone got?
We've discussed this back and forth with our facilities management and the company which provides this, and it came up that no matter what you do, whether it's wireless or wired, it comes to $1,000.
Okay. So $1,000 to install a single sensor.
To the whole package, sensor and installation.
Okay. So that would be specifically here.
And that was when we talked about CO2 sensors.
Right. Any other thoughts about what it might cost kind of out in the field? Say like random, I don't know. Again, I don't mean to pick on Deloitte, but like the Deloitte offices here, for example.
You mean in a building?
Yeah, and like in a typical commercial building. I'm curious to see the range of guesses people might have for what it costs.
Well, we come from the same school, discussing with the same people.
Right. Okay.
Everyone's
going to have the same number. So my experience is that to wire a sensor will range from about $800, let's call it $700 to, this is the highest I've seen, $22,000.
One sensor.
One sensor. Now, okay, that was in an airport. It's more complicated, there's security, contractors cost more, etc. But still, it's a $500 sensor, $22,000 to install. I think it's very, very typical to see a sensor installation costing 2 to 3 times the cost of the actual sensor. And the reason for this, this depends, of course, if it's a new building, very, very different. If it's a retrofit, if I wanted to put a sensor here, I would have to, first of all, it would be overtime because I can't do it during the day. So I need to come in at night, I need to cut a hole in the wall, I need to try and find where there might be cables. I probably need to run a cable, it's probably, well, here we're near a desk, so it's fine, but imagine if it was on that side. I need to run an Ethernet cable all the way across the ceiling, down the wall, cut a hole in, pull it out, plug it in, cover everything up, make it nice and neat again. It can be very, 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 very expensive to do that, especially you start to get to like more secure environments, doing that in the bank, triple the price. So a huge blocker here has traditionally been the cost of installation. With a fully wireless sensor, that cost can virtually go away. So I would have a conversation with the wireless and wired costs being equivalent, because we have a lot of installations where with a fully wireless solution, if it truly is kind of like the sensors that I was just showing there, they typically take 2 minutes to install and can be installed by an office admin, you or me, like anyone. There's no network connectivity required, there's nothing. It's just like you take it out of the box, you stick it on the wall, and you start getting data in the cloud. There's no reason for that to cost any more than about $5. So that, even if the sensors are the same cost, that has reduced the total cost of actually running a project by anywhere between 60 to 95%. So it's a real game changer. The key here is obviously that you need to have a huge amount of battery life, because if you have sensors that run for a year on battery, and you have, I mean, we did a project in the US with about 3,000 schools. 3,000 schools times how many monitors times how many batteries, you quickly end up with about 30,000 batteries that somebody needs to change. That's multiple trucks worth of batteries. You run into a big, big, big problem. But if you have, 8 years, a decade of battery life, that equation suddenly is very different. Yeah.
How do you deal with the heat that is generated by the batteries?
Batteries are actually much, much, much better, because if you are running a device that is running on battery, by definition must be incredibly low power consumption if it's going to last for 8 years. Like, incredibly low power consumption, therefore there will be zero heat generation. So actually the most accurate thermostats in the world will be battery powered. If you have wires, conversely, you're actually constantly pushing power into this thing and you're generating a lot of heat as a byproduct. So your typical thermostat actually suffers a lot more from that than a battery-powered device. So actually, if you compare our solutions, on a temperature, for example, our wired solutions, I'd say the spec is at plus minus 0.3 degrees Celsius for temperature, which is your typical kind of BMS sensor spec. For the wireless solutions, we can get that to about plus minus 0.1 degrees. So incredibly accurate. And the key here is also what kind of technology you're using for wireless. So we use like sub-gigahertz wireless that lets you get through multiple floors. So on a building like this, you might have a few kind of gateways throughout the building, and then all the sensors talking to those. If you're actually connecting to, for example, the building Wi-Fi, it'll never get through, is the short answer. Because you have IT to deal with, you have power consumption, you have networking. I've seen more projects than I would like to count just die because of these things. And when you think you found a solution for like one building, and then you take it to the next building, and they're like, yeah, we'll never do that. And there's just no way around it. In a corporate, in a company, so I said, message for anyone that's thinking about sensors, never do Wi-Fi. Wi-Fi is an absolute guarantee that projects will fail in the long term. Because no company in the world will let you connect to their corporate Wi-Fi, because it's a huge security gap. So just kind of quickly go through this. The other thing that we've learned over time is that sensor is, hardware is like one part of the equation, but everything that comes after that is equally, if not more important. Oops. So just kind of examples of that, like what are you going to do with this data? There are different use cases, which we can talk a lot more about, and this is more kind of at the corporate level, but sort of at a strategic level, if I'm managing multiple buildings, I want to understand, I want like clear KPIs. What percentage of time is this building meeting my standards? What percentage of time is that building meeting my standards? I don't want to get into the at a strategic level, I don't want to be thinking about room 307 and what the CO2 level is in there. But then the operational people and the kind of the analytical people, which typically would be like a facilities manager, they do need to see those things. However, they also don't want to see like a line for every room in the building, because you quickly run into scale issues. After you have to look at more than 4 rooms at a time, that just stops working. And you end up with these line graphs that have so many lines on them, they look more like abstract art than a useful tool. And so having the tools that like tie all these things together and turn it into simple outcomes that are easy to understand is really critical. I'll show you a couple examples of that. So I mean, this is just as sort of one example of this is kind of like our data platform, and you can see like multiple floors with the floor plans. You can see what's going on. There's a time scrubber underneath, so I can see sort of over the past 7 days or past 30 days. Sorry, this is quite small, but what's been going on in this space. I can kind of scrub through time and see how air moves around throughout this building, and then run analysis on that to get to like what's the root cause of the problem. I'll show you an actual case study. And then, yeah, there's a huge opportunity. We see a lot of people doing interesting things around sharing their air quality, be it on a screen, be it through little QR codes on the wall for people to kind of start to learn about what's going on. or being built into the systems that they use every day, like their calendar booking, or Microsoft Teams, or Slack, or whatever they might use, to be able to show all the people in the building, we are measuring this, we're working on improving this, and so on. So I kind of jumped through a few things quite quickly there, but I just want to make sure that most of the time could be spent on what we have learned along the way. Number one, the sensor technology problem has been solved. 10 years ago, there were no sensors. Everyone was trying to build a sensor because there was nothing out there. That problem has 100% been solved. Like I said, there are many companies out there that have 10, 20,000 monitors deployed across their global portfolios. The hardware is a solved problem. And the changes that we're seeing now are relatively incremental when it comes to hardware. The real changes on the hardware, and this is actually one of the other key learnings I'll share in a moment, is not around the ability to sense anymore. Like, the sensors are, as in the actual sensors themselves within the monitors, are very stable. They do a good job. There are some exceptions. There are some things that are still very hard to measure accurately, but the vast majority of things that we care about, are like, it's absolutely available today. So, and I think that's a note for kind of all the researchers here. A lot of people ask me, hey, like, I want to focus on indoor air quality. Where should I be putting my time? What would be most valuable to the global community in terms of research? I would say this would not be it. Trying to actually develop new hardware because it's a solved problem. Number two is battery-powered options are critical. For a new build, we always recommend going with a wired solution. For an existing building, wired solutions fail. It's too expensive. It's too unpredictable. You need to have a skilled technical person on board. Like, I cannot wire a sensor in this building. It's just not possible. Right? I need to have like an electrician, I need to have somebody with permission. I could put a wireless sensor in this building right now and just be done with it and not need anybody's permission. So if you think about schools as an example, like, you could just give every teacher a wireless monitor and say, put this on the wall, and then they can just go and do it. The moment you try to run something wired, it's a nightmare. And we see people try to sort of get around this by saying, well, we'll just use the plugs on the wall and run a cable down the wall and plug it in. That is an even faster path to failure. Because I guarantee you, every single monitor I've seen with like a USB-C cable going down the wall, you come back 3 months later and it's unplugged because someone wants to charge their phone. So, cannot go with solutions like that. And we have a lot of schools that unfortunately have gone with solutions like that because it's all that they could do. And the result is that if you look at the data, you just see like more and more devices dropping offline every month. If you look at a wireless solution, like, once they're online, they stay there. They don't go offline because there's nothing to cause them to go offline. So it's really, really important to have access to solutions like this. And then, having data is really only the first step. I've also seen a lot of projects fail because they collect this information and then it doesn't go anywhere and they don't really do anything with it. So even large organizations, in fact, sometimes these large organizations are the worst offenders. I won't name who, but we work with some of the largest tech companies in the world, and they'll say, no, just give me the data. We have all sorts of engineers on hand. We'll build all the tools to be able to analyze the data. We'll find all the problems, and we're going to build machine learning and AI algorithms to da-da-da-da-da. And you come back 3 years later, and you say, what have you done? You get nothing. Because it's a hard problem. It's a complicated problem. And it's very easy to just end up with a mountain of data and no useful outcomes. The other thing is that you really need to be able to translate that data into something that a facilities person can actually deal with. So, and again, this is kind of one of the more extreme examples, but if we think of schools again, typically the head of facilities in a school, came up, and this is, I'm speaking here to in the U.S. where we've worked on a lot of these kind of education projects, and the typical kind of career trajectory, somebody maybe started as the night watchman, and then they worked in security, and then they worked part-time in facilities, and then they ended up running the facilities for the school. If you suddenly present them with a highly complex, or like a scatter plot and a lot of the charts that researchers might want to look at, and you present that to the person that's trying to deal with the facilities, they were not going to know what to do with it. It needs to be translated into this thing is broken. It needs to be fixed, because they're also juggling so many different things. Typically the person who needs to deal with this also needs to make sure that the buses leave on time, the school buses. They need to make sure that the doors get locked, and they need to make sure that the air quality in the building is good. How are you going to do all those things? So you need to be able to take all that information and translate it to say, well, look, this piece of mechanical equipment stopped working 7 days ago. That's why your air quality is so bad. So here's a case study that kind of shows, I think, some of what you can do with this information. So this is actually a building in Australia. This is a Fortune 500 customer, and what we saw was VOCs super high at nighttime, and then they kind of dropped down during the day, but they were often still not very compliant during the day. So they're better, but not great. And so if you're looking, this is hours of day, days of the month here, and there's a very, very obvious pattern going on there, right? And if you look at this kind of just looking at all the floor plans, we're able to narrow it down to kind of a specific area and a specific floor and a specific set of rooms that had a problem. And when looking at those rooms, again, you see this very clear kind of trend. And then if you dial that down into a single day, what you see is that at around 7:30 every morning is when ventilation turns on. Ventilation comes on, and this is very bizarre. You suddenly see an enormous spike in VOCs, and then you see them drop down. Dropping down is normal because you're bringing outdoor air into the building, so you'd expect it to be flushed out. But why on earth does it go up? Well, long story short, this entire building, we were able to track it back down to a specific room, which was a mechanical room, which ironically was not even in scope for the tenant, right? That belongs to the base building, so it's the landlord's responsibility. But you're able to track it back down to a mechanical room. Turns out there's cans of paint in there. And so what's happening overnight, the HVAC shuts off, paint is off-gassing, it builds up in this room, and you basically have a really toxic room. The HVAC turns on in the morning, and what does it do? It takes all of that toxic air, and it distributes it throughout the entire building. And so now every room is terrible. And yes, after an hour, enough outdoor air starts to come in that it slowly dilutes all of this, and you get slowly back to more reasonable readings. But I mean, this is completely insane. This is an example of where if you did not have this data, there's no way you would ever be able to find this problem. It also points to, actually there's also another issue, which is that there is a upper and lower floors, the HVAC was turning on at different hours. So one part was turning on at 6 a.m., another one was turning on at 7:30 a.m. It's only 30 minutes before occupancy, which is not enough time to flush out a building. And so you can see very clearly, these are the upper floors, and these are the lower floors. And the upper floors are green, and the lower floors are red. And they all have this overnight VOC issue, but some of the floors are just able to flush it out more before people come in. So using this information, if you're able to identify these patterns, you can come up with very clear fixes, right? Run the HVAC earlier, get rid of the paint in the mechanical room, pilot this new HVAC schedule, see if it's effective. But this is the kind of information that needs to be given to a facilities manager. 3 bullet points, go do these things. A lot of those charts and graphs actually would just go over their head because they're busy dealing with too many other things in life. This is very, very, very fast. I actually wanted to do sort of a live thing, but because I can't get my computer online, just put a screenshot in here. this is an example of a building in Bangalore, and we're looking at PM 2.5 levels. What stands out as kind of strange looking at this? Any brave volunteers?
There's two rooms in yellow in the middle of it.
Exactly. I looked at this and I go, what is this? There's 4 conference rooms right in the middle of the building that have bad PM 2.5 and everything around them is good. How does that happen? Because PM 2.5 should come in from the outside. Well, it turns out that these 4 rooms, because they don't get enough ventilation, they have a dedicated outdoor air unit that is pulling air from the roof into those 4 rooms. And it turns out those 4 rooms, PM 2.5 levels track perfectly with the outdoors. And of course you go and you realize that nobody bothered to put the filter in. And we see this a lot. People put the filter in backwards, they put it in upside down, they put it in with the shrink wrap still on. They put in 1 filter, not 2, and so all the air just goes around the filter. It's amazing how many crazy things that you will see in this. And so, I'll try to kind of wrap this up quickly. The next key learning is also that AI is not the solution to all of our problems. Because there's a desire across this entire industry to think, well, if we just get all the data points and we bring them in and we have like an AI that's going to come and crunch everything and then do automation, and I should say AI and automation are not the solution. Because that example in Bangalore, there is no automation that can be done in the building that would fix it, because there's no filter inside. You do need something to tell you that there's a problem with it. And sure, you can use AI for that, you don't have to. But it's not an automation problem. It is a someone forgot to put a filter in problem. And I would say that at least 50% of the problems that we see are that. Some can be fixed through controls logic, but the vast majority actually are filter installed incorrectly, just like damper screwed shut. This week in Australia, I've seen 2 cases of where displacement ventilation was used. So the vents are on the ground and goes up to the ceiling. And someone was too cold, and so they just moved a bunch of boxes and put it on top of it. Super common. We see ducts where people are too cold, and so they find like some tissue paper and they stuff it inside the duct. The AI doesn't know there's tissue paper inside the duct, and the AI never will. And so garbage in, garbage out. If you only have half the picture, you're gonna look and say, or the AI is gonna say like, hey, this room is not getting enough cold air. We just need to increase, lower the set point and increase the volume of air. It doesn't do much if there's tissue paper in it. So yeah, the best control system in the world will only solve 50% of the problems. And that's great. It means 50% of your problems can be solved. It means there's 50% that are not going to be solved, and you need other solutions. And those solutions are human in nature. So it's about interpreting the data and turning it into an action that a human being with a wrench can go and fix. And the other thing is that every building is different, and this is like the biggest thing that I've learned. It's also why on that slide earlier I said we have like quite a few different products and different lines, because people, like this building maybe runs on BACnet. Go to India and nobody uses BACnet. It's all Modbus. People look at using like an API or thinking about, can I get data out of my BMS using an API? Every building is different, and so the key is around flexibility. And so again, this is kind of a word of warning or caution that from other projects that I've seen fail, and hope that nobody here ends up going down a path that I've seen play out many times before, which is like working on a specific project or a sort of small set of projects and coming up with a solution, but then you kind of step outside and realize that that solution is not going to scale. And then it just became kind of an interesting exercise in trying something out, but it's not actually a scalable solution to a problem. I spend most of my time basically working in product. So what that means is I spend like half the year just traveling around the world and talking to people, asking them questions. How does your building run? If we did this, would that be possible? And they're like, no, of course not. Like nobody in our country runs things this way. I'm like, oh, okay. like there went all our good ideas, and just doing that over and over and over again because it's every building is unique. Yeah, and then just don't let sensors sit on an offline network. Don't connect a sensor and like have it just go into the BMS. I'm all for like BMS integration, but we design all of our sensors to go to both the BMS, but also to connect to the cloud because it's so easy to get locked out of whatever system it is if it's offline. And you work on this great project and then you find yourself just like unable to access the data or do anything useful. Yeah, I'll skip through this. Don't really. I'll just this is kind of a good summary, and I'll kind of wrap up after this. The right way to choose an air quality monitor is yes, look at the tech specs, but also really understand what the goals of the project are and what's feasible. What's feasible in terms of power? What's feasible in terms of connectivity? Who's going to look at the data? How do they need to look at the data? And make sure there's answers to those questions to then choose what the best solution is. Because again, I've seen too many projects fail because they didn't ask the right questions. They just said, I need a monitor that meets these technical specifications for measuring PM 2.5. And there's 100 solutions that will do that. There's probably only 10 that are a good fit for your project. Yeah, and I've got some like, I'll share the slides afterwards because there's some useful information in here that I don't have time to sort of go through. But I just end by saying that like designing and procuring the system is only 10% of the battle. Like I said at the beginning, we started in the consumer space and we've gone into the kind of commercial, real estate, public space. And although we are still doing air quality monitoring, everything about it is different. We spend most of our time thinking about security. How can this connect in a bank? How can this ensure like privacy in schools? How can it, like there are 90% of the hard work is not actually making something that actually accurately measures air quality. That part is really the easy part of the battle. And I think that's also kind of a word of caution is that if you had asked me that 10 years ago, I would never have expected that to be the case. I would have expected most of our engineering and design and architecture work being like, how do I make an accurate air quality monitor? But it's not. It's like, how do I make a monitor that somebody can actually use? Because that part is a lot more complicated. So I know that took more time than planned. There's many other slides I could share, but I won't share. So that's a lot of me talking. I'd love to like have some discussion and Q&A.